let A be equal to 2I plus 3j plus 4k, and B be equal to 3I plus 4j plus 5k. Find the angle between these two vectors. Now I will take the easiest approach, and that will be using dot products. So we know that A dot B is equal to the magnitudes of the two vectors times the cosine of the angle between them, and this theta is what we have to find. This is the unknown that we have. And now firstly, let's find the absolute value, or the magnitude of this vector A. For this vector A, the magnitude is the square root of 2 squared plus 3 squared plus 4 squared, just taking the square root of the squares of all the components. And again, for vector B, this is for vector A. For vector B, you get 3 squared plus 4 squared plus 5 squared, all of that under the square root. This right here is equal to the square root of 4 plus 9 plus 16. That's equal to square root of 29. And this here is equal to 9 plus 16 plus 25, all of that under the square root, and that's equal to the square root of 50. Now, if you want to figure out the dot product of A times B, you will just do the component-wise multiplication. So 2 times 3 plus 3 times 4 plus 4 times 5 plus 4 times 5. This is equal to 6 plus 12 plus 20. That's equal to 38. Now given all of this, you can just put all of this into this equation. So you have 38 equals the square root of 29 times the square root of 50 times the cosine of theta, and you finally arrive at the cosine of theta being equal to 38 over the square root of 29 times 50. And this right here is something that wouldn't be expected of you to solve manually. If you can, that's really great. But anyways, the final answer, sort of in a nice clean form, would be theta being equal to the arcsine, or the inverse cosine of 38 over, and you can simplify this here as well. But in the end, you would get 5 times the square root of 58, and that's the answer to the problem.